In this video, I'll be going over arrays and slices. Arrays are fixed size memory regions, and slices are pointers into arrays. Here's a quick summary of arrays. Arrays represent a contiguous memory region. All elements of an array must be the same size, which means they all need to be the same type. Arrays are not dynamically sized, and their size is hard-coded in your program. In most cases, you will probably want to use a vector instead of an array. However, arrays are useful when working with networking protocols, crypto algorithms, and matrices. Here is the syntax to create an array. In this first line, we create a 3-element array with the values 1, 2, and 3. In the second line, we're creating the same array, but now we're using type annotations instead. Type annotations for arrays are surrounded by square braces, and the type will be indicated first, followed by a semicolon, and then the number of elements that are in the array. To write a function that has an array as a function parameter, you can use one of these signatures down here. This first one will move the array since there's no borrow, so we'll move a 3-element array that contains U8 integers into this function. On this second line, we will borrow an array that is composed of 8-bit unsigned integers. And on this third line, we'll also borrow an array that contains unsigned 8-bit integers, but we're going to be able to mutate it. So if we need to change the array, we'll need to have a mutable reference. Now that we've gone over arrays, let's take a look at slices. A slice is a borrowed view into an array. Slices can be iterated upon. They are also optionally mutable. Indices are bounded by the slice size, which means we cannot go out of the bounds of the initial slice. Each slice always starts at index 0 and ends at the index of the last element of the slice. Slices can create any number of subslices from an existing slice. Let's take a look at some more details to help solidify our understanding. Here is a visual representation of an array and a slice. So here we have a 10-element character array, and here are the indexes of that array. Down here we have a slice into a character array, along with the indexes of the slice. So as you can see with the array, it starts at 0, ends at 9, and we have all of the data nice and contiguous. If we slice into it by using the ampersand to slice and make a new character slice, we can slice, for example, at index 2, which will translate for the slice to index 0. We can end at index 5, and our slice will end at index 3. Because our slice only contains 4 elements. So when we create our slice, it only has access to this information in here. All this stuff outside of this slice, as far as the slice is concerned, no longer exists. So we have C, D, E, and F, and those correspond to indexes 0, 1, 2, and 3. The array still exists even though we sliced it, because remember, a slice is just a view into an array. So we're just viewing this one chunk of the array. Since you'll mostly be working with vectors in Rust code, it's possible to obtain a slice really easily from a vector. So if you borrow a vector and you send it as an argument to a function that requires a slice, then the function will automatically obtain a slice of that vector for you. And when you write functions that do require slices, you always want to borrow the slice instead of borrowing a vector. Let's take a look at what I mean. So here we have a function, and it has a single function parameter that is a slice of unsigned 8-bit integers. Now, if we were to send a vector, like we do here, we create a vector, and we just call the function, and we borrow the vector immediately, then it's going to automatically be turned into a slice for us by the function. Alternatively, we can get a slice directly from the vector by calling the asSlice function. And so the type right here will be a slice of 8-bit integers. The reason you'll want to write your function signatures to accept a slice instead of borrowing a vector is that slices allow the function to accept more types of collections, since a slice can usually be obtained from any data structure that's backed by an array. Vectors are backed by arrays, so the function works fine with vectors. When we create slices, we can use the range operator to get a specific range of a slice. If we take a look here, we have a vector of characters, A, B, C, D. And if we want just the BC, we can slice from 1 through 2. So this will be 0, 1, 2, and 3. So for BC, we're getting B and C, which is 1 and 2. Here on AB, we have 0 to 2. This is the exclusive range. So we'll get number 0 and number 1. 2 will be ignored since this is exclusive range and this one is inclusive range. Here's a visual of the above code. So we have our vector here on the top, and we have our indexes here, and here's all of our data. When we slice the BC slice, we're slicing out just this one chunk of data, and the indexes on the slice will be 0 and 1, which correspond to B and C. For the AB slice, we have our vector again here, and here's all the data. When we slice it, we'll have 0 and 1, which will correspond to A and B. After the slicing, we have no access to C and D, and we have no access to A and D in these cases. So this slice can only access this chunk, and this slice can only access this chunk here. We can also create sub-slices from existing slices. So here's the same vector we created before, but now we're slicing into the vector from 1 through 3, and we're then slicing into the existing slice, BCD, and we're getting 1 to 2. Let's take a look at a visual. So the first vector has all the information. So we have 0, 1, 2, 3, and it contains an ABCD. The first thing we do is we slice to get BCD, and then we slice again to just get CD here. So you'll notice on the second slice, it doesn't have access to B, and indexes 0 and 1 correspond to C and D. Because slices are restricted to their indexes as shown, subslices cannot carry any information about their parent slices. So this slice here doesn't know about B, and it definitely doesn't know about the first slice down here. So you'll want to keep this in mind if you're working with slices and you need to access the original data that you sliced from. This is a common thing you'll need if you're writing recursive functions. So all that means is with recursive functions, you'll want to carry the entire slice with you on each function call. So you just have an extra parameter which would represent the entire slice, and then you can work on that if you need to backtrack. To recap, arrays must be statically initialized with hard-coded lengths. Slices are a way to access parts of an array. Array-backed data structures like vectors can be sliced. Slice lengths are always bound by the size of the slice, and subslices can be created from an existing slice.